Though Oceans Are Made, a journey through Earth's history. Welcome back to the channel. Today, we're embarking on an incredible journey through time to uncover one of the greatest mysteries of our planet, how Earth's vast oceans were formed. Oceans cover more than 70% of our planet's surface and are essential for life, but their origin is a story that spans billions of years and involves complex geological processes. From the fiery beginnings of Earth to the role of icy asteroids and plate tectonics, this is the complete tale of how our oceans were made. Let's dive in. The birth of a planet, Earth's fiery beginnings. Around 4.5 billion years ago, the solar system was a chaotic place. Earth itself was born from a cloud of gas and dust that slowly clumped together to form a molten, rocky ball. This early Earth was incredibly hot, with a surface covered in liquid rock, and constantly bombarded by asteroids and comets. There was no atmosphere as we know it today, and certainly no water. But these violent beginnings laid the foundation for what would eventually become our oceans. As Earth began to cool over the next few 100 million years, the outer layer of molten rock solidified to form the planet's crust. But beneath this solid surface, volcanic activity raged on, continuing to shape the planet. Volcanoes would play a major role in bringing water to the surface, more on that shortly. At this stage, Earth's atmosphere was very different from what we breathe today. Instead of oxygen, it was filled with gases like carbon dioxide, methane, and ammonia, all of which were released by volcanic eruptions. The extreme heat and lack of a stable climate meant there was no water on the surface for millions of years. But things were about to change. The source of water, two competing theories. So how did Earth, a once molten and waterless planet, end up with the vast oceans we see today? Scientists have debated this for decades, and two major theories attempt to explain the origin of water on Earth. Volcanic outgassing theory. One of the leading theories is that water was always present deep inside Earth, trapped in minerals within the planet's mantle. As volcanic eruptions spewed out gases, they also released water vapor. Over millions of years, this water vapor accumulated in Earth's atmosphere, where it eventually cooled and condensed into liquid water, falling back to the surface as rain. At first, rain evaporated quickly due to Earth's intense heat. However, as the planet continued to cool, rainwater began to collect in low-lying areas, forming the first oceans. This process likely took hundreds of millions of years, but it laid the foundation for the large bodies of water that would later dominate Earth's surface. Icy asteroids and comets theory. Another theory posits that water was delivered to Earth by icy asteroids and comets early in Earth's history. Our planet was bombarded by these space objects in what is known as the Late Heavy Bombardment, a period when asteroids and comets collided with planets in the inner solar system. Many of these space rocks contained ice, and when they crashed into Earth, they released water, which added to the amount of liquid accumulating on the surface. Some scientists argue that up to half of Earth's water could have come from these extraterrestrial sources. Evidence for this theory comes from analyzing the isotopic composition of water found in ancient rocks and in meteorites, which show similarities with the water found on Earth. While these two theories are not mutually exclusive, it's likely that both processes contributed to the formation of our oceans. The combination of volcanic outgassing and extraterrestrial water delivery allowed Earth to accumulate the vast amounts of water necessary to form its oceans. The atmosphere and early oceans, Earth's cooling and the formation of liquid water. As water vapor accumulated in the atmosphere and began to fall as rain, Earth's surface cooled even more. This cooling process took hundreds of millions of years, but it allowed liquid water to persist on the planet's surface for the first time. Early oceans began to form in the large, low-lying basins that dotted Earth's crust. The first oceans were likely acidic, due to the high concentration of carbon dioxide in the atmosphere. This early atmosphere, which had been created by volcanic activity, was thick and composed mainly of greenhouse gases. The oceans absorbed much of this carbon dioxide, which helped stabilize the climate and make Earth more hospitable for future life forms. These early oceans were shallow and warm, and while they covered much of the planet's surface, they looked quite different from today's oceans. With no life to speak of and a constantly shifting crust, these oceans were in a state of flux. The water was filled with dissolved minerals from volcanic rocks and was much saltier than the water we know today. The role of plate tectonics, shaping ocean basins. While water filled Earth's basins, the planet itself was undergoing a transformation below the surface. One of the most important processes in ocean formation is plate tectonics, the movement of large plates that make up Earth's crust. Plate tectonics have had a profound impact on the formation, size, and location of the world's oceans over billions of years. Subduction zones. In some areas, tectonic plates collide and one plate is forced beneath the other in a process known as subduction. This leads to the formation of deep ocean trenches like the Mariana Trench, which is the deepest part of Earth's oceans, stretching nearly 36,000 feet below sea level. Subduction zones play a critical role in recycling oceanic crust and maintaining the dynamic nature of Earth's oceans. Mid-ocean ridges. Conversely, in other areas, tectonic plates move apart from one another, allowing magma to rise from Earth's mantle and create new oceanic crust. This process forms mid-ocean ridges such as the Mid-Atlantic Ridge, which is a continuous underwater mountain range that runs down the middle of the Atlantic Ocean. These ridges help to expand oceans over time and are vital in the creation of new ocean floor. Continental drift and the formation of modern oceans. Plate tectonics also played a major role in shaping the modern oceans. Roughly 300 million years ago, Earth's landmasses were joined together in a supercontinent called Pangaea. When Pangaea began to break apart around 200 million years ago, it created the Atlantic and Indian Oceans, among others. The opening and closing of ocean basins is a continuous process. Over millions of years, Earth's surface is constantly being reshaped by the movement of tectonic plates. Life's origin in the oceans, the cradle of life. The oceans weren't just vast bodies of water, they became the cradle of life. It is believed that life on Earth began in the oceans around 3.5 to 4 billion years ago. The first forms of life were likely simple, single-celled organisms like bacteria, which thrived in the warm, nutrient-rich waters of the early oceans. One of the most significant milestones in Earth's history was the emergence of photosynthetic organisms around 2.5 billion years ago. These organisms, like cyanobacteria, were able to use sunlight to produce energy, and in the process, they released oxygen into the oceans and atmosphere. This event, known as the Great Oxygenation Event, transformed Earth's atmosphere and oceans, paving the way for more complex life forms. Oceans continued to support life as it evolved. Around 600 million years ago, the first multicellular organisms appeared in the oceans, followed by the explosive diversification of marine life during the Cambrian explosion around 540 million years ago. Over time, more complex creatures like fish, mollusks, and coral reefs developed, making the oceans teeming ecosystems. Modern oceans and their importance. Today, Earth's oceans are vast, covering more than 360 million square kilometers and holding 97% of the planet's water. Oceans are integral to life on Earth. They regulate the climate, absorb carbon dioxide, and provide a habitat for millions of species. Oceans also play a key role in the water cycle, evaporating water that eventually falls as rain, helping to sustain life on land. They influence weather patterns, ocean currents, and even the distribution of heat across the planet. In addition, oceans are an important resource for humans, providing food, transportation routes, and even energy. They are deeply interconnected with Earth's systems and are crucial for maintaining a balance in the planet's climate and environment. Conclusion. The creation of Earth's oceans is a story that spans billions of years, involving volcanic activity, icy asteroids, and the movement of tectonic plates. From the formation of early oceans to the modern bodies of water that regulate our planet, oceans are central to Earth's history and its ability to support life. Without oceans, Earth would be a vastly different, and likely lifeless, planet. If you enjoyed this journey through time, don't forget to hit the like button and subscribe for more in-depth videos about our planet's history and natural wonders. Thanks for watching, and see you next time.